bright future. Every student matters.
Hello students, this is the fourth and last topic of this chapter, and the name of this topic is crystallization. We have to understand what crystallization is, and obviously it is a chemical change or not, we will be studying after that. It is a process in which a solid separates as crystals from its saturated solution. Now what is a saturated solution? Let us understand. For example, you have water, right? You have taken water in a bowl, or you can say a beaker, and you are adding sugar to it, right? You add 1 teaspoon, you dissolve it, it will get dissolved. You add 2 teaspoons, it will get dissolved. But there comes a time that there is a lot of sugar present in the water now, right? And you cannot dissolve any more sugar. The most of the sugar, or you can say maximum amount of sugar that can be dissolved has been dissolved. Basically, the maximum amount of sugar that can be dissolved in that amount of water, for example, you have taken 50 ml of water, has been dissolved. You cannot dissolve any more sugar into that. So even if now you keep adding sugar into the saturated solution, what will happen is the sugar will separate out. For example, you already had put the maximum amount of sugar in the water. Now you add 1 tablespoon again, right? Even after the saturation. Then the same amount of sugar that has been dissolved extra, that has been put extra, will separate out of the solution. And this sugar will settle down in the container. So this process in which the sugar that was dissolved in a solution and then the solution became saturated, the solution which has the maximum amount of solute dissolved in it, and there cannot be any amount that can be added to it now. It has the maximum amount in it. And then if you keep on adding it again, then the crystals separate out, right? This process of separation of crystals from the solution is known as crystallization. This is what we are talking about. The sugar that settled down from, basically it came out of the solution and it settled down in the form of crystals. This procedure is known as crystallization. The crystals obtained in this manner are highly pure. What is the use of this procedure then? We are now understanding the use as well, that the crystals that separate out are very pure, are highly pure. So crystallization is done intentionally as well to produce pure crystals of substances. For example, the sugar that has settled down here is pure. This sugar that you dissolved was maybe impure, it can be impure as well, it may have some impurities dissolved in it. But the sugar that is separated out of the solution as a result of crystallization is highly pure, right? Now, it is a physical change. It is a physical change, you can say. Why do you say that? Yes, it is a physical change only. It is a physical change. How is it a physical change? Let us look back to the sugar experiment again. You had 50 ml of water, right? You added sugar to it. After saturation, sugar separated out, right? And settled down at the bottom of the container, right? Sugar separated out of the saturated solution. Now what is happening here? You are adding sugar and you are getting crystals of sugar. So is there any new substance found? No, there is no new substance found. Sugar is obtained only after crystallization, right? And can this procedure be reversed? Yes, sugar can be separated from water by simply boiling. By evaporating the water, you can obtain sugar back. So there are no new products formed, and the change is reversible. So yes, crystallization is a physical change. No new products are formed. The initial substance that you had for example sugar in this case, is separated out as sugar only, but the difference is that the sugar now obtained is very pure, because the crystals are formed from the pure particles of sugar only, right? The impurities do not settle down, they remain mixed in the water solution, right? So yes, it is a physical change, but we obtain pure substances out of it, right? Now there is an activity for you to do. Take a cup full of water in a beaker. You have taken a cup full of water, right, in a beaker. Now add a few drops of dilute sulfuric acid in the water. You have added a few drops of dilute sulfuric acid. Heat the water, right? You are heating the water. You have it on a tripod stand and you are heating it on a burner. Now what? When it starts boiling, add copper sulfate water slowly. When it starts boiling, you have to add copper sulfate powder slowly. This is copper sulfate. Now, what did you do exactly? Copper sulfate is blue in color. As I told you, it is called blue vitriol as well. You have taken 1 teaspoon of copper sulfate and you have put it into the boiling water. While stirring continuously, you have to stir it continuously and add slowly, right? You have to keep it mixing, right? Keep on mixing it. Continue adding copper sulfate powder till no more powder can be dissolved. Basically, you have to prepare a saturated solution, right? You have to make a solution which has the maximum amount of copper sulfate dissolved in it, and you cannot add any more copper sulfate into it, right? Now filter the solution, right? Allow it to cool. You have to filter it and you have to let it stay. You have to let it cool down. Do not disturb the solution when it is cooling. You have to keep the solution fixed at a place. You do not have to disturb the solution at all, right? Now, after some time, look at the solution. Can you see crystals of copper sulfate? If not, you should wait some more time. After some time, you will notice that blue crystals of copper sulfate have separated out of the solution. These are the crystals and this is highly pure form of copper sulfate. Highly pure form of copper sulfate. Now what exactly happened? When you heated the water, its capability of dissolving copper sulfate increased. For example, if you have a normal water container with normal water, this is water at normal temperature, which is 25 degrees Celsius, and another container which has water at 100 degrees Celsius. It has boiling water in it here, right? It has boiling water. Now you add sugar to it, or you can say copper sulfate only. You are adding copper sulfate to both of them, right? You will notice that the first solution is able to dissolve 50 grams of water, while the second solution, which has boiling water in it, is able to dissolve 60 grams of copper sulfate. What does this tell you? This tells us that boiling water can dissolve more and more amount of copper sulfate. It can dissolve more amount of copper sulfate, but when you cool it down, now the capacity of water comes back to normal. So the extra amount of copper sulfate that has been dissolved will separate out of the solution in the form of crystals. So this procedure in which crystals are formed of copper sulfate, this procedure is known as crystallization. And the crystals now formed are again blue in color, right? The formula of these crystals are copper sulfate dot 5H2O. It has 5 water of crystallization present in it. This formula is basically CuSO4 dot 5H2O. You will be learning in detail about it in the higher classes. So what is happening? We obtained crystals of copper sulfate. Now students, you understood that you were adding copper sulfate, 1 tablespoon of copper sulfate into it, right? The initial reactant was copper sulfate only, and the product obtained is also copper sulfate, right? Copper sulfate was dissolved and copper sulfate is obtained. So what is the change? It is the physical change. There is no different product formed. We have just obtained the pure form of copper sulfate, and this is reversible. You can dissolve it in water again, right? So this is a physical change, and this is what crystallization is.